Hello everyone, welcome to this channel. I'm Payman Hisari. In this video, I will implement user-user collaborative filtering recommendation system on Amazon dataset related to over 2 million customer ratings of beauty-related products. The dataset link is in the description. Let's bring the data into the process panel and take a look at the data. As you can see, we have over 2 million rows of data with 4 features. The user ID is the unique identifier for each user. Product ID is a unique identifier for each product. And rating is the rating that a user has given to the product. And also we have timestamp, which is the time of rating, and it is in Unix time. We do not need this column, and we're going to remove it from the data set first. So let's do that. And in order to do that, I use an operator called select attribute. Bring the select attribute operator here. Connect it with this data set and configure this one. Because I'm going to remove one column, the type should be exclude, and the attribute filter type, I'm going to choose one attribute, and that attribute is timestamp. So if I run this process again and take a look at the results, I don't see that timestamp. In the next step, I'm going to make a copy of this data set, and I will explain why we need this copy of the data set using an operator called multiply. So bring the multiply operator here and connect these two. Multiply operator has nothing to configure, and it will allow us to use this data set more than once. Now, in order to build a recommendation system, we remove users who provided a low number of ratings and products which have received a few ratings to not introduce bias into the model. Let's first remove users. I need to count the number of ratings for each user, and in order to do that, I use an operator called aggregate. Bring the aggregate operator here and connect it with multiply operator and configure this one. For aggregation attribute, click on edit list, and the aggregation attribute is gonna be rating, and aggregation function is count. So I count the number of rating, and for the group, I'm going to use user ID, which means that for each user ID, I count the number of rating. And then I'm going to filter those users where their number of rating is below a specific number. And in order to filter them, I use filter example operator. Bring the filter examples operator here, connect it with aggregate operator, and configure this. So in add filters, and here I use count of rating to be greater than or equal some specific number, let's say 20. Okay. And if I run this process, this is the results I will get. So as you see, for each user, I have the number of rating, and the number of rating for all of them are greater than 20. Next, I'm going to join this with the actual data and get only those users from the original data set. And the operator is called join. Bring the join operator and connect these two together. And that's why I use the multiply. So I have the original data set and I get the original data set here. And I need to configure this one. And the join type is going to be inner, and the key attribute is going to be user ID for both tables. So the result of this join will be the original data set with users where the number of rating is bigger than or equal to 20. So as you see, we have the original data set, original user ID and product with their rating, and their count of rating is bigger than 20. But the number of data now reduced to close to 98,000. Next step is to remove products. And we will do the same thing, but for the products. Again, I'm going to choose aggregate. Bring the aggregate operator here. Connect it with this join operator. And let's rename this one to aggregate for products. And configure this one. Aggregate attribute is going to be, again, rating. And I'm going to calculate the number of rating, apply, but group by this time is going to be for product ID, which means for each product, I'm going to count the number of rating. Next, again, I'm going to choose a filter example operator to filter those products where the number of rating that they have received is higher than a specific number. Bring the operator here, connect these two operators together, and configure this one. For filters, click on Add Filters, and this one, again, count of number of rating should be bigger than or equal some number, let's say 15, and click OK. And I need to join this one again with the original data set to only use the original data set where the products have received more than 50 ratings. And again, I bring the join operator here. And connect it with this one. And with the original data set, which is from the multiply. And I need to configure this one. Again, join type is inner. And the key attribute this time is product ID. Apply. Now, if I run the process again, it will remove users who provided a low number of ratings and products who have received a low number of rating as well. And as you see, now we have almost 34,000 rows of data. And as you see, again, we have count of rating, which is not usable from now on. And I'm going to remove that one from the data set as well. And I remove that using an attribute called select attribute operator. Bring the select attribute operator here. Connect these two operators together and configure this. And I'm going to exclude this attribute, and the attribute filter type should be 1, and that one is count of writing. So now I only have that 3 column that I need to use for building a recommendation system. Next, I'm going to tell RapidMiner that rating is our target variable, and we need to predict that one. And in order to do that, I use an operator called setRule. Bring the setRule operator here, connect it with this one, and configure it. And the attribute name is rating, and the target role is gonna be label. And next, I'm going to split the data into the training set and test set using a split data operator. Bring the split data operator here. And configure this. For partitions, I'll use edit enumeration, add entry. The first partition is for training, and I'm going to choose 90% of the data for training, and add another entry and choose only 10% for testing the data. Okay. And the sampling type, I'm going to choose automatic, and I use local random seed in order to produce the same data no matter how many times I run the process. Next, I'm going to build my user-user collaborative filtering using an operator called user KNN. And bring the user KNN operator here, connect it with a split data operator, and configure this one. K is the number of neighbors that we use. By default is 80. I'm going to choose 80 by default. Minimum rating is 1. The range is 4 because the maximum rating is 5. So 5 minus 1 is 4. And there are other hyperparameters. I'm going to leave them as it is for now. Let's first build the model. And if the model does not produce a good result, then we can come back and change these hyperparameters. And because I'm going to calculate the performance of the model for both training set and the test set, I'm going to make a copy of this model using multiply operator. Bring the multiply operator here and connect it with user KNN, and multiply operator does not have anything to configure. And in order to calculate the performance of the model on the training set, I need to apply this user KNN model on the training data. And in order to do that, I use an operator called apply model for rating prediction. Bring it here. And apply model has 2 inputs. One is the model that comes from the multiply, and the other one is the data that comes from the user KNN operator. This is the data set, and it has nothing to configure. So the results of this will be a prediction of the model on the training set. So we have the prediction as well as the actual data, so we can calculate the performance of the model using performance operator. Bring this here, connect these two operators together, and configure this one. Again, minimum rating is 1, range is 4. And if I connect this one and run the process, I will be able to see the results of the model. So I'm going to rename this one. This is the performance for training. So this is the performance of the model for training. RMSE is 0.977, MAE is 0.75, and NMAE is 0.188. So this is the performance for the training set. I'm going to calculate the performance of the model for the test set as well. So I'm going to copy this to operator and paste it here. So this is apply model for the test data. So the model should comes from the apply model, and the data should come from the split data, which is the test data. And for the performance, I'm just going to rename this one. So this is performance for test data. And connect this one to the output and run the process. It will give us the performance of the model for both training set and test set. So this is again performance for training. For example, RMSE is 0.977 for training set, and RMSE for test set is 1.069.